a piece of gum. He was like, Brian, I'll give you the answer for gum. He's still chewing the gum I gave him. I didn't even take the answer.
From yesterday?
From today, last period. I didn't even take the answer.
Yes, you did. Why are you writing about
You better stop before I look up your schedule and then choose it.
Bro,
I do my job. Alright, so anyway, so properties of logarithms are just like properties of exponents. Like, if I told you how to do this fraction could be rewritten as a subtraction problem, yes? Everybody remember this? I didn't tell you this yesterday. Remember this example with this up here and you make it subtraction? Well, with logarithms, it's just opposite. We have subtraction. We're going to turn it into a fraction. We're going to go that way. So number one, to condense it, I'm going to do a base 4, and I put the 48 over the n. And I make it one logarithm. See that? Similar. Fractions and subtraction are connected when it comes to exponents, and logarithms really are just exponents. So now we want to, we have the same base, so the same log, we can cancel logs. And now we just have a little linear equation. Solve that. That's not anything new to you. I would multiply n on both sides. If I go too quick now, I don't know. 4 by 6. 8. Okay, so with common logarithms, if it's subtraction, you make it into a fraction. If you're condensing. You can go the other way as well. Another thing we practice with exponents is if you had to do x to the 4th times x to the 6th, you would add those to get x to the 10th. So multiplication and addition are connected. And it's the same with logarithms. With addition, you condense by making a product. It's a product property. So number 2, I would rewrite it log base 3 of 2x times 7. I don't need both those logs in there. I can just multiply those arguments. And then you have the same log on the left and right, so you can drop the logs and equate arguments. Do this all the same stuff. So this is 14x equals 28, which means that x is 2. One more. This one looks different. And it's really important to note that there's so many different ways these equations can be presented. Like, you might be on a roll and then all of a sudden something like this comes up. I see that it's addition, so I'll condense and multiply the arguments. You guys have to do this.
I already did it.
Okay, good. I'll leave it. I'll do it. Okay. I was gonna change it. Alright, so what's so different about this one is that we don't have the log on both sides. So we don't have this opportunity to cancel the logs and equate the arguments. what can we do instead? Yes. Anytime you're stuck, actually I'm gonna write this out. If there isn't log on both sides, convert to exponential. Something you want to convert to exponential form. Something you want to try to get in the habit of. I know right now you're stuck not thinking of it, but I can write this as a big base 3. Logarithm solve for exponent, so the exponent is 1, equals 3a squared plus 9. And now you don't have log anymore. This is no longer a logarithmic equation. It's now quadratic. And I'm going to solve by square rooting. Minus 9 on both sides. Divide by 3. Negative 2 equals a squared. And now we will square root. Plus or minus I square root 2 equals a. Any questions on that one? It's an imaginary answer. It's a little tricky. So we should check it. Yes. So graphing complex numbers happens on the complex coordinate plane. Instead of x and y, you graph the real part here and the imaginary part here. That being said, if this was a function, this would be a y, right? So it's not a whole line right now. Yeah. So this is like a point I can plot here. It's actually right here and right here. But it's not a two variable function that you graph. Alright, so you should be questioning, could this happen? Let's check it. So I am gonna check it. I'm gonna put this value in for a. So it's gonna be I square root 2 squared plus 3. And the rule is that this has to be positive, that any argument in the log has to come out positive. So this would be I squared and the square root of 2 squared plus 3. Does anybody remember what I squared is? Negative 1. And the square root of 2 times the square root of 2 is 2. So this is actually negative 2 plus 3, which comes out to be a positive 1. So when I plug this complex number into that set of parentheses, you actually get an argument of 1, which is still within the parameters of the definition of log, so it works. That's a little technical, but good practice. Let's look at your assignment from yesterday. Page 99. Keep your notebook open because the problems we're about to do, they kind of take a lot of space. It was 11 through 18.
How do you know? Are you on your phone?
You're surfing. You gotta hit the surf. Who's driving you? Yeah. What about protection? What else you get to surf? I know, that's what I'm saying. One of those Volkswagen vans, little vintage vibe going. Is there like a Honda? All right, you guys, we're actually going to go to the top of this page. Does anybody have any questions? All right, we're going to learn this real quick. We're going to do 6 of these. I didn't cover these yesterday. And these are problems. They're set up real interesting. They're designed to make you practice the properties. So before calculators could do different bases, mathematicians had books of charts and tables. So for instance, if we had to figure out 2 to what power is 15, like in number 5, and this isn't that long ago, like teachers in their 60s, this is how they learn. Okay, I'm thinking 2 to what power is 15? I know that 2 to the 4th is 16. So this is 2.39 or 2.38 or something. So I would open up the textbook that I have full of all of the exponents ever, and I would find the answer there. Okay, so somebody calculated all these exponents and wrote them down in tables and charts. And then we just globally mass produced it and passed it out to everybody who did math, and they just always referred to this. And at some point, I'm sure it's on the internet, but now our programmers put it in our calculators so that we don't have to refer to these books. But so somebody did 2 to the 3rd and got 8, and then they did 3.01, and then they did 3.02, and then they did 3.03, and there's just records and records and records of all these numbers that people did by hand. It's like a lifetime of numbers. So they would use smaller arguments. Like here we have all of these can be thought of, they're all log base 2. And they have lots of different arguments, but we only have 2 numbers to use. We have log base 2 of 3 and log base 2 of 5. And we're going to rewrite all of these arguments just so that we can use those. Let me show you an example. Oh. Okay. So for instance, I don't have 25 in my book, and I'm not going to use my calculator. I'm going to rewrite 25 as 5 squared. This is page 99, you guys. So same as yesterday, but you probably want to do it on notebook paper. This is the only thing really new I'm telling you today. So 25 is the same as 5 squared, and everything here I want to rewrite in terms of 3 or 5, because those are the only two numbers I know. So I'm going to use the power property and put this in the front. So this is 2 times log base 2 of 5. And now I can replace this with the one number I do know. So this is 2 times 2.3219. And that's like, math that you could do by hand. So, or put that in a calculator, but you have to show all the work. So go ahead and multiply it, and that's our answer. So this is just an exercise in rewriting numbers, seeing numbers in different ways, and problem solving and critical thinking, how you can look at a number differently. We're going to do 1 through 4 and number 6. Baden, you got your calculator, right? Go ahead. 2 times 2.3219. Okay, number 2. You guys try to rewrite it. I showed you one. Think about how 27 could be written differently. You can see it's kind of been the theme of all second semesters, seeing numbers as bases and exponents, and understanding numbers beyond what you have before. What's the next move? Power property. And I know what log base 2 of 3 is, so now I just do 3 times 1.585. Rewriting my numbers. You got it, Brian? There you go. All right, then, same concept. So we actually call this expanding. So here I said the word condense several times. And now, working with this, we want to actually expand it. So a quotient is related to subtraction. So I'm going to rewrite this as log base 2 of 3 minus log base 2 of 5. And that's expanding. This is definitely like kind of a big topic covered in college algebra, pre-calculus. You'll all be doing this again next year. So the more time you take now to understand it, the better off you'll be next year. Well, it is only like 3 steps, and these are like 6 steps. What's that math? Alec. I have in mind that the only logs I know are argument 5 and argument 3. So I'm viewing all of these numbers in terms of 5 and 3. Did that really answer your question? All right, let's skip to number 5. What are you doing, Bean? So, everybody's getting calls. We're ignoring them. I ignore my phone calls. It's easier because I'm not looking at my phone right now. How can 15 be rewritten in terms of 3 and 5? 15 is 3 times 5. 15 is 3 times 5. So, Brian C., what does multiplication correspond to with logarithms? So now that we've written this as a product, we can now expand it to an addition problem. So we're working our properties the other way. And I know both of these numbers. I'm using my tables, my charts, my record book that I've purchased, or right here in our workbook. We already have these decimals done for us. So you guys should check this one, like after we add it. I'm going to add this, and I get 3.9069. So one way to check and show that you truly comprehend this, which you might not just yet, is I would do 2 in my calculator to the 3.9069, and it should give me a 15 out, or it's the closest to 15 that, I don't know, I need to look up one of these books, to be honest. Oh, I have 4 more. It's 15.000097778. Well, it was like their life work. You know, they were like lords, and they weren't doing regular menial jobs. They're academics and intellectuals and mathematicians, like these people on these posters, you know. What are the people called that were like scholars? I think I'm thinking of like the Age of Enlightenment, and it was way after that. But yes, when people didn't have to work and they were just like princes and lords, and they had people who did their cooking and their cleaning and took care of their children, and yes, they explored academics and numbers and the stars, and that's who figured out a lot of the science because they didn't do anything. Philosophers. There's a lot of philosophers that did this math. Anyway, if you check this, it comes out really, really, really close to 15. So we have to keep going on that to get even closer. Do we need to do any more? That's it? Actually, I did want to do 45. Number 6, I did say out loud to do this one. I don't want to cut you short. So how can we write 45 in terms of 3 and 5? Well, when I think of 45, I think of 9 times 5. Yeah. So I'm starting with 9 times 5. And so that gives me log base 2 of 9 plus log base 2 of 5. Now, I don't know 9. I only know 3. So I'm going to now go further and rewrite 9 as 3 squared. And now I'll have to use the power property and put that to the front. And now you're ready to sub in the decimals. Trey, what's your question? Can you? So subbing in the decimals, that's 2 times 1.585 plus 2.3219. We can check this too. Hey, if you had to guess, 2 to what power would be 45? 2 to the 5th is 32, and 2 to the 6th is 64. So our answer should be between 5 and 6. 5.53? So close, baby. $5.49. I just said it was between 5 and 6. So I'm going to check this. It's 45.00. It's not even as close as I wish it was. Anyway, I think they were using logarithms to estimate the distance to like the stars and across the oceans. Logarithms really came for people that were estimating distances across oceans. So, I don't know, you can look it up. I'm so sorry. Yes?
Can you try one of the ones on?
Yeah. All right, I am now headed to today's assignment. So that's it. You guys can start your assignment. Aiden, 10 to what power is 35? Well, 10 squared is 100. So go back. Okay, 0.12 is our prediction here. All right, so the only logs I have are 5 and 7. So I'm going to rewrite this 35 as 5 times 7. And then I'm going to expand. That's log base 10 of 5 plus log base 10 of 7. Alec, we good there? Well, now sub in your decimals. This one is 0.699. And this one is 0.8451. What do you remember what your prediction was? 1.